Hello, ladies and gentlemen. Welcome to Module 2, CCNA 2, Cisco, Switching, Routing, and Wireless Essentials. Again, this is Module 2. So let's get into this. Let's get going here. We're going to talk about switching concepts in this video. We're going to explain how Layer 2 switches forward data. Okay, so frame forwarding. Explain how frames are forwarded in a switch network. Okay, keep that in your brain there. Switching domains. Compare collision domain to a broadcast domain. So we're going to take a look at those items here. But before we get into that, let's take a look at this here really quick. I'm going to put these two little graphics on the board here really quick. Okay, let's get this up here because this is important. Again, when we talk about networking, I talk about the very simplicity of things that we do in our everyday life, things that we see every day, the normal stuff that we do as it pertains to networking, IT, cyber, all that good stuff, right? So if you take a look at this, we have our wonderful USPS truck. This is a mail truck, and this is our letter. Okay, take note. Okay, take note. Look at our letter right here. What's unique about our letter? We have our sending address, right? We know where it's going. And we have our address on where it came from. So we have our destination address and we have where it came from, right? We also have the delivery method on how it got there, right? In this case, we're using the UPS truck, right? So keep those concepts in mind. So before we get going here, I want you to watch this video. All right, we're going to watch this video. And you might be thinking, why are we watching a mailman delivery mail? I don't understand why we're watching this, but just check it out. Check it out. Turn it down here just a little bit. All right, so we got a gentleman coming in the mailbox. He's going to this mailbox. Looks like somebody left it open. It's okay. He's coming in. He's got the flashers on. Okay, so right off the bat, I'm just going to ask you a question. I mean, you should know. You probably already know the purpose of this mail truck and this mailman. What is he supposed to do, right? He's more than likely going to get out of his car, out of this truck, and he's going to deliver mail into this mailbox, right? So let's pay attention. Let's watch this really quick. Okay, let's watch. So he's going to get out, he's getting everything together, he's getting all of the mail, and he's putting mail on top. Let's stop it here for a second. What is he doing here? Let's take a look at what he's doing here. He's actually getting ready to open up the different mailboxes right here, right? The different mailboxes. Pay attention here. Pay attention. Now he's opening the whole thing up, right? So I want you guys to think of this for example, okay? Is it fair to say that this mailbox right here is on a street that contains a lot of other homes, right? I would say so. So if we see that he's getting ready to drop mail into this box at some point, okay, these individual slots probably belong to individual homes on the house, right? Would you agree that maybe inside this mailbox there might be a little list for him to put the mail in so he knows which address goes to which, right? Okay. So for right now, I want you to think of this mailbox as a switch, a networking switch. Let's go on to the next video. Let's pause this really quick. Let's see here. All right, so let's take a look at this video. We saw the mail truck show up with the packages, drop it off into the mailbox. And I specifically told you that mailbox. I want you to think of that thing as a switch, okay? Now, let's watch this video really quick, and then we'll break it down. Let's take a look at this video. Looks like we have a bunch of mail packages being delivered. Okay, as you guys see there. Keep watching. Let's see here. Now we have a conveyor belt. All right. Now we have a belt that's moving. So we have trucks that bring in data or packages, and now it's going on a belt. Okay. Keep watching. let's go back. I'm going to go back in just a quick second. I want you to think. Let me erase this really quick. I want you to think of this factory as one big switch, big networking switch. Okay? This factory is one big networking switch. And all of these bay doors, let me back up here for a second, right here. All of these bay doors, okay, these are Ethernet connections with an RJ45 to a computer, okay? And these are the ports that are coming in, offloading data into the switch. And as the data comes in, okay, it gets transferred in to a certain area of this switch, and you know what's going to happen to it once the data comes in, right? It's got to find a way to go out to its destination, right? It's got to find a way to go out to its destination. So let me speed this up really quick because I want you to see something else here. See it again? These packages are coming off the conveyor belt and they're dumping it off into specific areas, okay? Very similar to a switch. It's going to dump it off into specific ports, right? So would you agree if it's going to do this, like here's a good example, if it's going to drop off after it scans, okay, after it scans, before this package leaves, would you think it's a good idea? Would you think that maybe this switch knows exactly where it needs to go and which port it needs to go out of? Would you say so? I would say so. If you said yes, I would say so. Because that's exactly what's going on here, folks. Okay? Acts just like a switch. The data comes in. It knows the port that it needs to get to. It should have the destination. And then it dumps it off right into the areas where it needs to go. Very, very similar to a switch. All right, so let's talk about frame forwarding, because I'm sure you saw a lot of forwarding going on in there, right? When you saw that video, when you saw the packages that were coming in, as soon as it came in, you saw some forwarding happen, right? When it started going down to different channels or different ports, right? Like I said, very similar to actual switch. So let's get into this. Switching and networking. The two terms are associated with frames entering or leaving the interface, okay? Ingress, entering the interface, and egress, exiting the interface. So we have ingress, entering the interface, and we have egress, exiting. A switch forwards based on the ingress interface and the destination MAC address. So you should know what a MAC address is. Okay, the MAC address is that physical address that's stamped, basically on the hardware, on the NIC of all those devices, right? Some the Bluetooth, whatever it is, that MAC address is static. It does not change. A switch uses this MAC address table to make forwarding decisions. I want you to keep that in mind. A switch uses its MAC address table to make forwarding decision. Let's go on the next one here. The switch MAC address table. A switch will use the destination MAC address table, okay, to determine the egress interface. Before a switch can make the decision, it must learn what interface the destination is located. Before a switch can make the decision, it must learn what interface the destination is located. So if you remember in that video that I showed you, there was a part when the packages were coming in, and as soon as it came in off the truck, okay, i.e. Ingress, right? When they were coming off the truck, they were getting scanned. After they got scanned, you saw where it got forwarded. Very similar to this. Before a switch can make its decision, it must learn the interface that destination is located, right? It's got to have the MAC address table, right? A switch builds a MAC address table, also known as a content address memory, by recording the source MAC address table into the table along with the port it was received. So when that data comes in, it knows where it came from. If you remember earlier, I showed you that piece of mail. It had the destination address and it had the source. It knows where it came from. The switch learns and forwards method, okay? So the switch uses two-step process, okay? Step one, it learns, examines the source address, right? It adds the source MAC if it's not if it's not a table, right? So the source MAC, if it's not in the table, it'll add it. If it's something brand new, if it's something new that's showing up, it'll add the information. Step 2, forwards examines the destination address. If the destination MAC address is in the MAC address table, it will forward it out the specific port. Now watch this. If the destination MAC address is not in the table, it is flooded out of all the interfaces except the one it was received. So let me explain this to you. If the destination MAC address is not in the table, it is flooded out of all the out of all of the interfaces except the one that it was received. Okay, so pay attention to that. This is kind of like sitting at a restaurant, right? If you're sitting at a restaurant, waiter shows up, got a big table. Hey, who ordered such and such? It's flooding all the information out, right? Very similar to that. Okay, we already kind of looked at the video here. Now, switching forwarding methods. Switches use software and application-specific integrated circuits to make very quick decisions. A switch will use one or two methods to make forwarding decisions after it receives a frame. Okay, let's take a look at that. Store and forward switching. Receives the entire frame and ensures that the frame is valid. Is valid. Now, I want to point this out. Let me finish the rest of this. We're going to go back to this here in a second because there's cybersecurity involved in this. Cut-through switching. Forwards a frame immediately after determining the destination MAC address of an incoming frame and the egress port. But let's go back to this first one here. Store and forward switching. Receives the entire frame and ensures that the frame is valid. Okay, because the reason why I bring that up is because I want you to understand that cybersecurity is big right now, right? Cyber is in everything, even in networking, everything we do as it deals with cyber. Let me show you something really quick. All right, so I want to show you this picture. This here is what we call the CIA triad, okay? And the way I view this, okay, we have a lot of religious faiths that are out there. People may pray to different religions as they want to pray to. When it comes to cybersecurity, network, and IT, this is kind of like our Bible, right? We operate in this space when it comes to information tech, cyber, all that good stuff. So you may be asking me, you may be wondering, like, okay, why are you showing me cybersecurity stuff, Mr. Tanya? That this is networking. I want to know how things switch from different networks, things of that nature. The reason why I'm bringing this up is because cyber is in everything IT. Everything we do has to deal with cybersecurity. Okay, so let's go back to this really quick. If you notice here, it says store and forward switching receives the entire frame and ensures that the frame is valid. So let's go through this really quick. Let's look at the C when it comes to CIA triad. What does the C stand for? Confidentiality. Pretty simple, right? Let's look at the I, integrity. And let's look at the A, availability. So things that are confidential, your banking account information, social security cards, social security cards, credit card numbers, things of that nature. Things that you don't want people to see, that is confidential. Integrity. Is it real? Is it yours, right? Is it encrypted correctly? Okay, are you checking hashes? Are the hashes matching up so the data doesn't move? Things of that nature, right? That is integrity. Is it what you originally put forth, right? How would you feel? I know it happens on social media all the time. If your account got hacked and somebody changed a post that you posted 2 days ago and they changed the wording. That's an integrity issue, right? Availability. When something goes down, it's not available. So we want to have high availability, right? So if we understand these principles, you understand that cyber is in everything we do when it deals with networking. So let's take a look at this here again. Store and forward switching receives the entire frame and ensures that the frame is valid. Ensures that the frame is valid. So I ask you, if we want to make sure that the frame is valid, what part of the CIA triad does this affect? And if you said integrity, you are absolutely correct because that is the correct answer, integrity. Let's go on to the next one. So store and forward switching. Store and forward has two primary characteristics. Error checking, There it is again, folks. There's the CIA triad. Error checking. Make sure everything's good. The switch will check the frame check sequence for errors. Bad frames will be discarded, right? Buffering. The ingress interfaces will buffer the frame while it checks for the frame check sequences. So it's making sure, like, yo, man, make sure everything's good. Want to hurry up? Everything's good. Everything's fine. We'll let you in. This also allows the switch to adjust for potential differences in speeds between the ingress and the egress ports. Cut-through switching. Cut-through switching forwards the frame immediately after determining the destination MAC address. So once it knows the MAC address, it's going to cut it through, right? Fragment-free method will check the destination and ensure that the frame is at least 64 bits, right? This will eliminate runts. We'll talk about that here in a little bit. Concepts of cut-through switching. It is appropriate for switches needing latency to be under 10 microseconds. It does not check the FCS, so it can propagate errors. So it just moves like it needs to be. May lead to bandwidth issues if the switch propagates too many errors, right? Bandwidth. So think of that freeway when we talk about the bandwidth. A lot of cars on that freeway, a lot of room for that data to move, right? And cannot support ports with differing speeds going from ingress into egress. So let's take a look at switching domains. All right, so let's take a look at switching domains. So if you remember in the video number 1, I showed you that flag man that had those cars going in different directions, right? He would hold the sign up saying that car can go, and it would stop. Another car would go. Half duplex, full duplex, the full freeway, full duplex, if you guys remember that, okay? So switches eliminate collision domains and reduce congestion. When there is a full duplex on the link, the collision domains are eliminated. So if you take a look at this picture, okay, we have the auto negotiation going on, right? This is kind of like that 4-way stop sign. Everybody's auto negotiating who can go. Everybody's operating all at once, right? There's no flashing reds or anything like that. Everything's good. Even that freeway that's moving. Half duplex is essentially when if you were to go to a light and maybe one light is flashing, the other light is working correctly. One side is working green, the other one's not, which would be crazy because that would cause a major collision, right? Very similar to that. They're operating at different speeds, as you see here, right? At different speeds. So when things are at different speeds, you're going to have a collision, right? Not unless we have the auto negotiation. Broadcast domains. A broadcast domain extends across all layer 1 and layer 2 devices on a local area network. Only a layer 3 device, a router, will break the broadcast domain, also called a MAC address broadcast domain. The broadcast domain consists of all devices on the local area network that receive the broadcast traffic. Okay, so if you remember to, when something comes in on the ingress, if it doesn't know the MAC address table, it's gonna flood it out, except for the ingress port that it came into, right? When the layer 2 switch receives the broadcast, it will flood it out all the interfaces except the ingress. That's what I've just said it. So too many broadcasts may cause congestion and poor network performances. So if we're seeing a lot of broadcasters that are going out, that may flood that freeway a little bit, right? We may not have enough. Cars may be moving really slow, kind of like the 10 freeway in Pomona. It's just slow sometimes at 4 o'clock right there by Fairplex. It's bad, right? Very bad. Increasing devices at layer 1 or layer 2 will cause the broadcast domain to expand. So elevated network congestion. Switches use the MAC address table and full duplex to eliminate collisions and avoid congestion. So if we go back to that video I showed you of that factory, all of those packages coming in and out, right? Operating at full duplex. Very important. Features of the switch that elevate congestion are as follows. So fast port speeds, depending upon the model, switches may have up to 100 gigs. Fast internal switching. This uses fast internal buses and shared memory to improve performance, and you can see the rest of the information here. Okay? Very important there. So let's take a look at a demo here. All right, so let's take a look at a demo that I have set up for you here. Let's try to see this in action here. All right, so if you take a look at my network that I have set up here, I just have 4 machines. And so just for context, let me blow this up a little more here. So for context of this demo for you, I have PC1, PC2, PC3, PC4. Let me show you one of the configurations on one of these machines. I went on ahead and configured these IP addresses of all of these machines. This particular computer is 192.168.1.11. Take note of the subnet mask. It is WAC24. This one is going to be .12. Okay, there's .12, .13 and into 3, and .14 and into 4. So I did not set any default gateways because we're not dealing with the router because we're all here on the same network, right? I have a console cable hooked into the switch, so let's get into the switch right now. Let's take a look at the switch. Let's take a look at the So we're going to go to terminal, and let's take a look at a couple items. Now, for the sake of this, typically what I like to do, and I explain this all the time, especially in IT, especially when it deals with cyber, security, IT, all that good stuff, right? The first thing you want to do, typically you should always lock down your networking devices. Always lock it down. Enable secret passwords, service passwords, security. Make sure everything, nobody can get into it, line counsel, message of the day, all that stuff. You should lock everything down. But for the sake of this, we're just going to assume everything is locked down. We're just going to get right into it for the sake of this demo. All right. So let's take a look at what we got here. All right. So before we start, let's take a look in the switch. Let's see what we got going there. I'm going to put in the show command. All right. So I just typed in the show MAC address table. What do you see here? Nothing. You don't see anything switched here, right? So right now, this switch has no data. It's like a brand new switch, just plugged in. We don't see anything. Nothing is in there. Not at all, right? Zilch, nada, nothing. We don't see anything on this table. So there's no table that's been developed in this switch, right? So we're going to come back to this. So let me pin this down here. I'm going to put up the simulation here. And what we're going to do, we're going to ping one of these machines. So let's go into PC1. And let's go into the command prompt here. And we're going to ping, I believe it was 192.168.1.12. I think that's what it was. Let's double check here. Make sure I have the correct IP address here for this. Yep, .1.12. All right. So before I even start this Marco Polo, this ping, what do you think is going to happen here? What do you think is going to happen? All right. You can kind of think about that on your own. So let's try this. Let's hit simulation. I'm going to press enter. All right. So first things first, let me shorten this up a little bit so you can see this. Okay. We already have the packet getting ready to start. We have that envelope already started. All right. There's the first initial. Okay, so I'm speeding this up. There's the first initial. It sent the communication to that switch. Here's the ingress, the ingress, right? The port that's coming in. What do you think is going to happen next once I advance this simulation? If you go back to what we talked about in this video already. When data comes in, if it does not know the MAC address table, what does it do? It floods it out all of the ports except for the one that it came in on. Because the switch knows it doesn't need to go there because that's where we're trying to get the information. So let's fast forward to this. We should see a broadcast, right? We should see a flood to all of these switches. And there it is. So if you take note, this is our target computer. As you can see, we have the red X here, and we have the red X here, all right? Let's take a look at some of these frames here. So we can blow this up here. So this is our destination MAC, right? There's our ARP, our address resolution protocol. And by the way, just so you know, the reason why ARP works is because it knows ARP is designed to take the IP address and match it to the MAC address, so it ARPs. So only for ARP to work, it needs to know the IP address. That's how that works. MAC addresses work a little different. So as you can see this, source IP .11, destination IP .12, okay? It's going to ARP. It says, hey, we are coming for .12. Here's the destination IP, right? That's what we're trying to get to. Now, what's going to happen next? I'm going to advance this. PC2, which is .12, comes back and says, hey, I hear you looking for me. I hear somebody's looking for me. Let them know that I'm here. Then it sends that data back to PC1 and says, hey, man, I'm here. I found you. Then it goes back again. Then we see it again. Then it goes back. It says Marco, Polo, Marco, Polo, Marco again, Polo, Marco, Polo. So this computer is responding to the ping commands, as you can see here, right? Okay, I have to advance that, right? So now, let's take a look. Let me reset this here. Go back to real time here. Now let's take a look at our switch table. Let me blow this up a little bit more so you can see this. Go to desktop. Oops. Nope. Let's go back into terminal. All right. Turn this on. All right. Now, if you remember last time when I ran this command, as you can see, there's nothing here. What do you think is going to happen now if I run it again? Voila. Now the computer or the switch has now learned the MAC addresses to these two PCs, right? So now it knows exactly when that data comes in, it knows where it needs to go. Very similar to that video that I showed you earlier. When those packages comes in, it forwards it automatically right out to the port it needs to go to. Right? Very, very important there. All right, so let's ping another computer. Let's go into PC2. And let's ping this computer here. And I believe this one was a .13. Yes, it was, .13. So let's go into PC2. Go to command prompt. We're going to go ping 192.168.1.13. We're going to hit that ping command. Look at all those replies, those Marco Polos. And we have those Marco Polos. It says Marco Polo. It responded back. And now we have all the information. It just happens in a matter of seconds, right? Now, let's go back to the switch. Let's go into terminal. Right now, the MAC address table only has 2 entries in here, right? There's only 2. Let's see if there's more entries now. There indeed is. There's a 3rd MAC address table that has now showed up. All right, so as you can see from that video, those switches were building those MAC address tables, right? Every time I pinged the machine, went back into the switch, typed in show MAC address table, you can see the MAC address table building. You can see those physical addresses that are attached to that switch. Very similar to that video I showed you. As that data comes in that big warehouse, those packets get offloaded, those bay doors or those switch ports, same thing. As soon as that data starts coming through, it gets processed and scanned. As it's going right back out, when it starts diverting, it knows that MAC address table, right? It knows that door that it needs to go to, all right? All right, I hope you liked this Module 2 video on switching concepts. Make sure you like and subscribe to the video. Follow me at TandyIT. See you on the next video.